Okay, so we're going to go through the multiple choice part of test D. So there we have the first question. It says, which compound is not an isomer of the following compound? So when we're looking at this, what we're really trying to do is making sure that we can work out the molecular formula. So for this compound we would have C4, 4 carbons, 8 hydrogens and an oxygen. And then a quick check first to make sure that all those would have the same. So in order to be an isomer, we'd have to have the same molecular formula. The first three do have indeed C4H8O. However, the last one, if you calculate carbons, hydrogens and oxygens, you would have C4H6O. So clearly that can't be an isomer of the cyclic compound, so it would indeed be D. Question 10 then. Which alcohol forms a mixture of alkenes when dehydrated? You've got a number of options there. The easiest thing here is to sort of think about, well, dehydration, that's elimination. I'm going to, as it say, make an alkene. So I personally would draw out a quick sketch of which ones there are there. So you've got your propanol, one O on the end. That would dehydrate. You take the OH off and the hydrogen on the carbon next door. So we've ended up with our propene. Propan 2-ol, similar. We've got OH in the middle. That one would dehydrate, and again, you take the OH off, but you'd end up with the same alkene. Pentan 1-ol, so we've got the longer chain. 1, 2, 3, 4, 5, and then our OH on 1. That would dehydrate. You take the OH off at the end, and then the hydrogen from the one next door. So again, we'd end up with alkene on the end. And the bottom one then, you've got 1, 2, 3, 4, 5. However, this time we've got pentan 2-ol, so we've got OH there. That would dehydrate. You take the OH off. If you take the hydrogen on the right, then you would indeed end up with similar to above in terms of the alkene. If you take the hydrogen on the left carbon, the one in the middle though, you would end up with the alkene being in a different position. So indeed, D is the only one that will lead to a mixture of alkenes. Question 11 then, it says, what's the most suitable reagent for deciding the presence of carbonate? So the presence of carbonate in the presence of sulfate ions as well. You should be thinking carbonate, what do I do with that? I do a test for acids, so acid plus carbonate gives me salt plus water plus carbon dioxide, and I would see some fizzing. So I need to look down my list to decide which one's an acid. And looking down those lists there, the only one that's an acid is my dilute sulfuric acid. Question 12 then, a bit of a calculation. I've spilt some acid. I want to clean it up using sodium carbonate solution. So I've got my amount of acid, there's my volume and my concentration of my acid, and it asks me the minimum mass of anhydrous sodium carbonate I'd need to neutralise that. So I first need to think about a balanced equation for the reaction. I would take my HCl, react that with sodium carbonate, making sure I've got the correct formula for my sodium carbonate. That would give me my salt plus water plus carbon dioxide. I then need to make sure that's a balanced equation. So I've got my Na2CO3, so I need 2 of my NAs there, and therefore I will need 2 of my HCls. So firstly I'm going to work out the moles of my acid, because that's the thing I've got 2 things about, the volume and the concentration. So my moles, HCl, will be volume times by concentration. The volume, remember, needs to be in decimeter cubed, so I'm going to take, I'm going to take my 50 and times it by 10 to the minus 3. Then I'm going to times it by my concentration, which is 2. That will give you my moles of acid, 0.1 mole. Then need to look at my balanced equation. I can see on the left that from every 2 HCl's I only need 1 Na2CO3. So therefore I need to divide by 2 to find the number of moles of carbonate that I would need to neutralise that with. So the moles of carbonate will be my moles of acid divided by 2. And that's my moles of carbonate. They want the minimum mass here. So I have to do a mass equals Mr. Moles, therefore I will need to know the MR of my carbonate. Again, making sure I've got the correct formula. So when I add up 2 times my sodiums, 1 times my carbon and 3 times my oxygens, I'll get 106. So then my mass will be mass equals Mr. Moles. So your MR, which is 106, times by the moles, which we just worked out to be 0.05, that will equal 5.3, and it always comes out in grams. Therefore, that's B there on the answers. Question 13 then. So this is a question that says heat release by 1 gram of ethanol gives 29.8 kilojoules, and it wants you to calculate the heat released per molecule in joules as well, okay, when it undergoes complete combustion. So first work out the moles of ethanol. Okay, that will be my mass over my MR, so my mass is 1 gram divided by, and in this case they gave you the MR, so 46. 0.0217. That's my moles of ethanol. So my molecules of ethanol will be my number of moles times by my Avogadro number, which they've given us. So 0.0217 times by 6.422 times 10 to 23. That will give me my number of molecules. And I want the heat per molecule in joules. So I need to take the heat energy, there we go there, 29.8. That's in kilojoules. I need it in joules, so I'm going to times that by 10 to the 3 to take that to joules. And then divide that by the number of molecules I have, which is in this case 1.309 times 10 to the 22. That will give me 2.28 times 10 to the minus 18, which indeed is A. Question 14, they've given you some particular elements, and it says which set contains a simple molecular lattice. So we want a simple molecular one, a giant covalent lattice, and a giant metallic lattice. So with giant metallic, we need something that's metallic, we need something covalent, and we need something simple molecular. So indeed, if we look at the top one, we've got our sulfur. Remember, sulfur is S8, it is indeed simple molecular. The silicon is a giant covalent. And the aluminium is indeed your giant metallic. So we don't need to look any further. We've got the ones at the top that we need. So answer is A. Question 15 then. Looking at an equilibrium, and we're asked to work out the total amount of moles in an equilibrium mixture. We're given some things about where we might start and sort of end up with, so we're looking at doing a Rice calculation. So we just write our equilibrium out again. We've got our NH3 going to N2 plus H2. Then I would write down my ratios. Remember your ratio. So you've got at the beginning, you've got 1, because it says you've got 1 mole of ammonia. At the beginning, you've got nothing. Oh, that's what I wanted to stop. I want my ratio, don't I? So I want 1 2 half, 2, 3 over 2. So 1, 2 a half, 2, 3 over 2. There we go, before I start writing anything else. Then I want my initial. Let's put my initial in. So with my initial, I start with 1 mole, so that's why I find there's 1 mole there, and I start with 0 of my things at the beginning. And then what I'm told is that 50% of it dissociates. Okay, so 50% has gone, you've only got 50% left. So if I start with 1, half of it must have gone, I must have half of it left. So remember, I'll be writing my change in my equilibrium. Yeah. So at equilibrium, I know then that I've got 0.5 moles left because 50% is dissociated, so 50%, half of it, is left behind. So I can work out my change because this is the one that I've got most information about. So that will be minus 0.5. So 1 take away 0.5 will leave my 0.5, which I know I have. Therefore, I need to work out the changes in the other one. I look back and I look at my ratio. So my ratio of ammonia to nitrogen is 1 to a half. So I would change the other one by half as much. So I'll be adding 0.25 there. And then the hydrogen is 1 to 1.5. So I'll be changing that by 1.5 times my 0.75. So I'd be adding 0.75 there. 1 times my 0.5. Pardon me. So therefore, in terms of my actual amounts, at the end I would have 0.25 that one and 0.75 of that one. Okay. It asks for the total amount, so total amount of the gases at equilibrium. So then all I need to do is add them all up. I need to add 0.5 to 0.25 to 0.75. That will equal 1.5 moles of gas in total. Therefore, the answer is A. So question 16, another calculation. It's told you that you've got a formula here of XCl2. Okay. And it also says that you've got so 0.24 grams of X is reacted with 0.01 of your chlorine to form a chloride. So you've got X plus your Cl2 to form some sort of chloride. Okay. And therefore you know that if you've got 0.01 as it says of your chlorine, you'll need 0.01 of your X. Okay, you therefore know that as well. Mass equals Mr. Moles. We want to work out the MR in order that we can then decide on the formula. So that will be your mass divided by your moles. The mass is 0.24 grams. The moles, we just said there, is 0.01. That will give us 24 for our MR, which indeed would be your magnesium. Magnesium, B. This one asks us to work out the oxidation number of the nitrogen, and you've got a nitrate in the middle there, so you've got NO2. Remembering that all nitrate ions are negative, and then in terms of oxidation state, my oxygens are always -2 each, so that's total -4. I want to leave a negative behind, so my nitrogen, in order to balance that, needs to be +3. And indeed we've got there B +3. Question 18 then, which compounds are formed by the acid hydrolysis of phenyl methyl ethanoate? So figuring out what that is first. In terms of an ethanoate, okay, so we're looking at an ester, so we want our ester bond in the middle. Remember, the first part of the name comes from the alcohol bit that attaches to the single bond oxygen. The second part of the name is from the carboxylic acid. So we must have made that from ethanoic acid in terms of the ethanoate bit. And then the alcohol bit is a phenyl methyl. Phenyl group, and I know we've just started to do aromatics, so possibly not as familiar. And then we need to look at that and say, okay, well, when I acid hydrolysis of that, okay, so hydrolyse that, which bond am I breaking? I'm breaking that bond there. To revert back to, because I'm in acid conditions, I will revert back to the carboxylic acid, which would be ethanoic acid, but that's not the bit that it asks me to do. Okay, so that would be the acid bit, which comes from the acid. So, and also then we would then have the alcohol bit, so OH onto CH2. So we need to look for that, and indeed it's the top one there we found, A for that compound there. So question 19, which monomer could form this polymer? We've got a carbon-carbon only backbone going along there, so we must be looking at an addition polymer, so we're looking to make from an alkene, therefore we're really considering the bottom two. And in terms of that, we need a carbon that's got, so when we draw it out in terms of putting them back again, we'll put the double bond back in again in terms of the alkene. We will have a hydrogen off one of them, another hydrogen, and a CN, an H, and a CN. Okay, so that would be the alkene as such. However, we want the polymer, so in that case, we need to make sure that we have the correct thing, and so indeed we'd have CH2, CHCN, so we'll be looking at C. So question 20 then, which sample contains the greatest number of stated particles? So we just need to work out really how many particles we've got there, or the number of moles really. So 1 gram of hydrogen, we'll be looking at mass over mR as such, so 1 over 2 will give you 0.5. In terms of helium then, 1 over your AR there, so 1 over 4, or mass over your AR will give you 0.25. 1 decimeter cubed of hydrogen molecules, so that's remembering then that 1 mole would be equal to 24 decimeter cubed. So 1 decimeter cubed equals 1 divided by 24, which equals 0.04 moles. Similar to the bottom, if you've got the same volume, they'll be the same number of moles there. So you've got again 1 over 24, which equals 0.04. And we're looking in this case for the greatest number, therefore you'll be looking at A, you've got 0.5 of that. So question 21, which compound can react with ammonia to produce propylamine? You have a number of selections there, but in terms of wanting to make propylamine, so with your NH2 on the end there, I've got to add ammonia in order to make that. So that's thinking, what type of reaction do I know that makes amines? We should be thinking about halogen alkanes undergoing nucleophilic substitution, because ammonia is a good nucleophile. Therefore, we need a halogen alkane, so you need the same chain as what would be in your amine. However, you now need a halogen on there, and indeed put the Br there in terms of reacting to form your amine by a nucleophilic substitution. It's not the alkene here, it's indeed the bromoalkane there. And the last one then, what is the correct observation? So we want to see something we'll see when we put barium metal to an excess of water. So that's thinking what's going to happen when I do that. I'll be looking at my barium metal, I'll be adding that to water, and that's remembering that makes the hydroxides plus hydrogen, just to balance that as well. There we go. Yeah. So observations around that, what am I going to see? Barium hydroxide, bottom of the group hydroxides, they're soluble. In terms of looking at group 2 solubilities of the hydroxides, they increase, you come down the group, so that's very soluble. Obviously the hydrogen there, you will see some fizzing, effervescence, etc. So which one goes with that? It forms a colourless solution, which it would do, and it effervesces, means it fizzes, therefore we're looking at D.